How to create mobile respawn points in Arma 3. This video will be the first in a series of tutorials on how to make a mobile respawn. And in this video, we are going to look at the method you usually find on the web. This method involves using a marker as a respawn point and running a loop that updates the position of that marker. This method can also be used if you just want a marker to follow an object in a mission. This script tutorial is built up with different rounds, with a warm-up round, a bronze round, a silver round, and a gold round. The scripts in each round will build on the scripts from the previous rounds, getting more advanced, but each script is final in each round, meaning you can leave with a working script already in the warm-up round. In the warm-up round, we will look at the basic setup. Then, in the bronze round, we will take that script and modify it in 3 ways to better handle the situation when the object the respawn marker is connected to is destroyed and possibly respawns itself. In the silver round, we will take these scripts and modify them to be more reusable and dynamic, rather than static as the way we originally wrote them. Then in the gold round, we'll take what we have learned and write a new script that will create its own marker based on the data we feed the script when we call it. But before we begin, we need to make respawn markers work. To make this work, you need to set the respawn type to custom position at the very least. You can enable this setting through the multiplayer attributes in the Arma 3 editor or in the description XT file by adding the following code: respawn equal 3 or respawn equal base. If you want the players to have a choice between different positions, you can also enable the menu position option for respawning. This is not required in this method, but if you are using more than one respawn point, I recommend activating the menu position setting. You can set this option in the multiplayer attributes in the Arma 3 editor or through the description XT file by adding the following code: respawn templates equals menu position. Or if you already have a respawn template, just drop this inside it, menu position. Now if players need to respawn and a respawn point is available, they will have the option to choose the respawn location. With that covered, we can start warming up with our first script. Ordinarily, to make a marker a respawn point, we just need to name it respawn in the variable name. Nothing more really. However, if you have chosen to use the spawn selection setting, you need to define its side. Additionally, if your mission involves players from different sides, you should also define which side owns the respawn, even if you don't use the spawn selection. To do that, we will add a suffix to the end of the variable name. The suffixes we can use are _west, _east, _gorilla, and _civilian. If it says west, blue 4 will get the respawn. East, red 4 will get the respawn. Gorilla, green 4 will get the respawn. And if it says civilian, the civilian side will get the respawn. If you want to add more respawn points, just add an underscore and a number after the respawn or suffix. Now, place down a marker. Empty markers are great because they are invisible in-game, but you can use any type of marker you want. Here, I'm going to select the hospital marker and set the color to red for up 4. Then, I'm going to give this spawn the variable name respawn _east _1. So this respawn point is going to be specific for up 4. Now I need a mobile object. This can either be a player or a vehicle. I want a medical vehicle, so I'm going to use this one. Then I double click on it and give it a variable name. I chose to name it ambulance _1, but you can name it whatever you want. Just be sure to give it a variable name you can call later. Then we are going to create an SQF file named mobile respawn. Again, you can name it whatever you want. Just remember this name. Now open that file up. Inside, we are going to create a while do loop. A while do loop will repeat the code inside it as long as the given condition returns true. We are just going to put down true here, so it will always be true. The loop will now run multiple times per frame and hurt your performance. So we want to add a suspension. So inside the do bracket, we are going to put down the code sleep 3. This will make the loop wait for 3 seconds before it starts again. You can put down whatever time you want. Just remember, the higher the number, the longer the time for updating the position will be. The lower the number, the shorter the time for updating the position will be, but the code will run more often. Now we are going to move the sleep code down a line, and above it, set in this code, marker, set marker pause position. Marker is a string, and inside it, we place the variable name for the marker we want to manipulate. Set marker pause is the code that will move the marker. Position is where the marker is going to be moved to. This can be an array or an object. So we want respawn underscore east underscore 1 to be moved to the position of ambulance underscore 1. This means the code will look like this. Respawn underscore east underscore 1 set marker pause ambulance underscore 1. Now that the loop is set up, it will continuously run whenever this script file is called. It will first fire the code that sets the marker's position to where our object is located, and then it will pause for 3 seconds before starting again from the top. But this file is not yet called, so if I start the mission now, this script will not be active, so we need to call it. To call this file, create an init server SQF file inside the mission folder. Unless one already exists, then just open that. This file is executed only on the server when the mission starts. We want this loop to run only on the server, not on every machine in the mission. Open this file, and inside it, write down the following code. exec vm mobile respawn sqf. exec vm will compile and call the SQF file, and here that file is the one we created before. And that's it. Now if you start a mission with this setup, you will see that the marker moves to follow the vehicle or person you have designated. If you want to have more respawn markers connected to different vehicles, just copy the script file, fire it from the init server, and replace the variable names of the vehicle and marker with the variable names you want for the other vehicles and markers. If you have more markers, I recommend using the menu position option for respawning.
But what if the vehicle or player in the script is destroyed or killed?
As the script is set up now, the loop will still run, and the code inside it will still execute. But the marker will not be moved until the loop runs again after the vehicle or player respawns. This is often not ideal, because it means that players will respawn where the connected object was neutralized, which may not be a safe space. We have now warmed up, and we can head into the bronze tier. Let's see how to modify the script to better handle the situation when the object is neutralized. We are going to create 3 script versions, so I recommend copying the file mobile respawn sqf and putting it somewhere so you can paste it in later. I'm going to have these 3 versions running beside the first version for presentation, so I'm going to rename the copies to mobile respawn underscore A, mobile respawn underscore B, and mobile respawn underscore C. I will also copy the vehicle and the marker and paste them 3 times. So I have 3 more vehicles named ambulance underscore number and 3 more markers named respawn underscore east underscore number. The first version we are going to create is one where the marker follows the object when the object is alive. But when the object is dead, the marker is set at a fallback position. We could do this with an if-then-else statement. An if-then-else statement will execute the script inside the then bracket if the condition specified in the if bracket returns true, and execute the script inside the else bracket if the condition returns false. So when the object is alive, the marker gets moved to the object's position, and when it's not, the marker will get moved to a fallback position. In this case, the fallback position is a static position, and that makes a solution like this not the best one. Because why fire this code more than needed? One could add more sleep time to lower the instances of this code getting executed, but the code may still be fired more than needed. So we're going to use another method. This will kind of make an if then else statement, but instead of using that statement, we are going to use two loops. First, let's create the fallback position. Here, I'm going to use an empty marker with a variable name, fallback pose, and place it near where the vehicle is going to respawn. Now we can open the mobile respawn _ASQF file. The first thing we are going to do is copy the whole script. Then just paste that copy inside the loop so it will look like this. Then you go into the while bracket for the inner loop and change the condition from true to alive ambulance _2. Then change the marker's name to respawn _east _2 and the object's name to ambulance _2. And that's all we are going to touch on in the inner loop. Now under the inner loop, still inside the outer loop, we are going to write a new instance of the setMarkerPose code. Like the instance of the code inside the inner loop, this code line is scoping to our respawn marker, respawn _east _2. But the position is not going to be the object, instead it will be a marker. So we need to write it like this. Respawn _east _2 setMarkerPose get marker pose fallback pose. What this says is that the position of the respawn marker will be set at the position of the marker named fallback pose. Under this code, we are going to write a wait until statement. This statement will pause the continuity of the script, here the outer loop, until its condition returns true. By placing in the condition alive ambulance _2, it will look like this. Wait until alive ambulance _2. This will make the outer loop stop here and wait until the object is alive. But like the while do loop, this statement will loop and check if the condition returns true every frame. We don't want that, as it can tax the system too much. So we're going to write in the sleep code here too. The code will look like this. Wait until sleep 5. Alive. Ambulance _2. A very important thing to note is that the sleep statement needs to be before the condition statement. So what have we done here? We have created a nested loop, a loop inside a loop. When this script is fired, the outer loop will start. When it reaches the inner loop, the outer loop will pause and wait until the inner loop has stopped. When the inner loop's condition is no longer true, the outer loop will continue its run. When the outer loop loops around again, if the inner loop's condition returns true again, the loop will pause again when the outer loop reaches the point of the inner loop. How we have set it up is that the outer loop will pause right after moving the marker to the fallback position. Here, it will wait until the object has respawned, then it will loop around and restart the inner loop. Since we are using an inner loop with the same condition as the wait until statement, which also has a suspension, this will create two pauses inside the outer loop. I chose not to add a sleep code inside the outer loop, since the outer loop is going to pause at its start and after the inner loop has been broken. But if you have a setup without a wait until statement, I would recommend adding a sleep at the end of the loop. Take note when using nested loops. If the inner loop is active, it will not be broken if the outer loop is broken by its condition no longer being true. The script will not continue before the inner loop has also been broken. So if you want to break both loops, you need to ensure that the inner loop is broken before the outer loop. This case can't happen with how our conditions are, but if you change them, you should keep this in mind. Now remember, open the init server SQF file and paste in execvm mobile respawn _ASQF. And that's it. Now, if you start a mission with this setup, you will see that the marker moves to follow the vehicle or person you have designated. When they are neutralized, the marker will move to the selected fallback position, but when the object respawns, the marker will start following it again.
But what if I want the players to have a vehicle that doesn't respawn and wish to remove the respawn point when it's destroyed?
In the next version, we are going to look at that. The second version we are going to create is one where the marker follows the object when the object is alive, like before, but when the object is dead, the loop is going to stop and the marker will be deleted. To do that, there is not much change needed from the original script. We are just going to change the condition in the while loop from true to alive, ambulance_3. Then, after the loop, we are going to place in a delete marker code. So let's open the mobile respawnb.sqf file. Inside the while bracket, remove true and set in alive ambulance_3. Then inside the do bracket, just change the numbers at the end from 1 to 3. So the marker would be respawn_east_3 and the object would be ambulance_3. Then, after the while do loop, write in this code delete marker respawn_east_3. Delete marker will delete the specific marker. Here we have named respawn_east_3 as the marker we want to delete. When the ambulance is no longer alive, the loop will break and the next code in the script file will be fired. That code is the delete marker code, which will delete the marker that is the respawn point. Now remember, open the init server SQF file and paste in execvm mobile respawn_bsqf. And that's it. Now, if you start a mission with this setup, you will see that the marker moves to follow the vehicle or person you have designated, and when they are neutralized, the marker will be removed and that respawn point will no longer be an option.
But what if I want the players to have a vehicle that respawns and wish to remove the respawn point when it's destroyed, but have it reappear when it's respawned?
We are going to take a look at that too. For that, we are going to base our script on what we recently did in our two previous variants. Here, we are again going to have a nested loop in the script. Then, after the inner loop is broken, we are going to have a code that deletes the marker, then have the outer loop pause and wait for the object to respawn. After that, we are going to have some code that recreates the marker, then let it loop around. The first thing you can do is take the mobile respawn_a SQF file and copy it. I'm going to name the copy mobile respawn_c. Or, if you have already made one, just open mobile respawn_a and copy its content over to mobile respawn_c. Now in the new file, just remember to change the number 2 to 4. So where it was ambulance_2, now it's ambulance_4. And what was respawn_east_2 is now respawn_east_4. After that, the first big change we are gonna do is replace the code setMarkerPose, which is under the inner loop, with the code delete marker. So it would look like this: delete marker respawn_east_4. Now after the inner loop has been broken, the marker is going to be deleted. And then the outer loop is going to pause on this code and wait for ambulance_4 to respawn again. When it's respawned, this condition is going to return true and the loop will continue. Now, after wait until, we are going to use this command. Create marker, name, position, channel, creator. Create marker is the command to create a marker. Name is a string variable where you specify the name of the marker. Setting a variable name makes it easier to call this marker in later scripts. Position refers to the location where the marker will be placed. This can be an array or an object, and you can also use position commands to obtain a specific position. Channel is set to the default value of -1 or none, which allows you to specify the channel where the marker will be placed. However, I recommend leaving this field empty. Creator is set to the default value of obj_null. This variable allows you to specify who created the marker. Along with the channel, this can make the marker visible only to players in the specified channel. But as with the channel, I recommend not filling this in. So our code will look like this. create marker, respawn underscore east underscore 4, ambulance underscore 4. Now this is all we need for the loop, but this marker is going to be invisible. It's going to work, but the spawn point is not going to have any special name or visibility on the map besides the spawn map. For the sake of presentation, we are going to look at how to set the marker type, color, and text. To set the icon of the marker, you want to use this command, marker set marker type. Marker is a string variable where you put the variable name of the marker. Set marker type is the command to set the marker type, which determines the icon the marker uses on the map. Type is a string that refers to the class name of the marker you want to use. You can find a list of names on the page CFG markers Arma 3 on the Bohemia Interactive Community Wiki. We want our respawn marker to have the hospital icon, so we will write our code like this. Respawn underscore east underscore 4 set marker type log hospital. Next is the code set marker color. This code has a similar structure to the previous code, where we start with a string that defines which marker we are going to call. Then we have the code which sets the color of the marker. Then we have a string that specifies the color we are going to use. One can find a list of marker colors also on the Bohemia Interactive Community Wiki, this time at CFG marker colors Arma 3. So we want our marker to have the op4 red color. So our code will look like this. Respawn underscore east underscore 4 set marker color op4. Now our next code is the one that will set the marker text. This text is also what one will see on the respawn menu in the list of different spawn points. The code is set marker text and has the same structure as the two previous codes, where one starts with a string. This string is the variable name for the marker you want to edit with the command set marker text. Then, after the code, we have a new string, which is the text that will appear on the marker. My code is going to look like this. Respawn underscore east underscore 4 set marker text, remove and reappearing. But you can write it like this. Respawn underscore east underscore 4 set marker text, ambulance, or nothing. Now with this, the marker is visible on the map, has a color, and has text. And now remember, open the init server, SQF file, and paste in execvm mobile respawn underscore c sqf. And that's it. Now, if you start a mission with this setup, you will see that the marker moves to follow the vehicle or person you have designated, and when they are neutralized, the marker will be removed. But when the object respawns, the respawn point will reappear, and this will loop. Congratulations! You have now finished the bronze round. You should now have an understanding of how to create nested loops, how to delete markers, and how to create them in a script. You can now leave with this knowledge, as every version of these loops we have created can stand on its own. However, if you stay, you may learn how to make these scripts more effective. You may already have discovered that this setup can lead to errors in the script. Just one mistake in the variable names or a moment of forgetfulness will cause the script to throw an error. You may also have noticed that if you want to use one of these scripts for more than one object, you have to copy and rewrite the script. This is inefficient, both time-wise, as you need to change the variables inside the script for each different scenario, and storage-wise, as you need a separate script file for each active respawn point. What we are going to do now in the silver round is streamline these different scripts, so you don't need to open them every time and change the variables when you want them to work with new objects and markers. Our goal is also to ensure you don't need to copy the file each time you want to use it in the same mission. So let's advance up the tier, now to the silver round. The first script we are going to look at in this round is the first script we made in the bronze round. We are now going to rewrite it so that the script does not use specific names for the object and markers, but instead uses local variables whose arguments we provide when calling the script. For easier understanding, first head to init server, SQF. Here, inside the square brackets, before exec VM mobile respawn underscore a SQF, we're going to make a list. Write the variable for the object you want the marker to be connected to. Here, I'm going to write ambulance underscore 2. After that, write the marker you want to move. So for me, respawn underscore east underscore 2. Remember to write the marker's name as a string using quotation marks. After that, write the marker you want to be the fallback position, fallback pose. Again, markers need to be written as a string, so the array is going to look like this. Ambulance underscore 2, respawn underscore east underscore 2, fallback pose. Now open the mobile respawn underscore a SQF file again. Inside this file, and before the loop starts, we are going to put in 3 local variables, and we want them to be protected from overwriting, so we are going to set them as private. First, let us write the first variable. Start with private, then write underscore saveambulance equal sign str underscore this select 0. Underscore saveambulance is the name of this local variable we create. Underscore this in this instance refers to the array in front of exec VM. Select will select an element from the scoped array, and 0 is the position of the element that will be selected. The numbering of positions starts with a 0, so the first position is numbered 0, not 1. Str will make the selected variable a string. We will discuss later why we do this. Then we are going to write the second local variable. Start again with private, then underscore spawn marker equal sign underscore this select one. We don't use str here, since we use the quotation marks in the square brackets to define the marker's name as a string, but you could choose to remove the quotation marks in the square brackets and define it as a string here with the code str. You can also remove str in the first variable code and use quotation marks in the square brackets to define it there as a string. The third local variable is going to look like this: private underscore fallback pose equal sign underscore this select 2. As mentioned earlier, these 3 variables will select the arguments we gave in the square brackets when calling this script file. So in this instance, underscore saveambulance will be the string name of the variable ambulance underscore 2 since it selects the first parameter, underscore spawn marker will be respawn underscore east underscore 2 since it selects the second parameter, and underscore fallback pose will be fallback pose since it selects the third parameter. And remember, the position starts at 0. What this means is that we can call this script multiple times, with different parameters like ambulance underscore 1 and respawn underscore west underscore 2, or ambulance underscore 2 and respawn underscore west underscore 1. And we don't need to copy the script file and open it to change the variables.
But why are you turning the object into a string? When you called the object in code last time, it was not a string.
Yeah, how should I explain this? Let's first talk a little about variables. We have 2 kinds of variable scopes: global variables and local variables. A global variable is accessible from any script in the mission after it has been defined. It maintains its value and state throughout the entire runtime of that session. If the value of a global variable changes in a script, it will also change in all other instances where it is used on the same machine. However, even though it's called a global variable, it doesn't mean the variable has the same value on every machine in a mission. For the variable's value to be the same on every machine, a change in the value needs to be broadcast to every machine. To broadcast a global variable, you need to use the public variable command or set the public argument to true when using the setVariable command to define the value. A local variable, on the other hand, is only accessible within the script or code block in which it is defined. It's not accessible outside of that script and will be discarded when the script finishes. So a variable name is essentially just a global variable in the mission namespace, which has a unique object as its value. In the editor, you can only assign one variable name to an object. However, through scripting, you can assign multiple variables to an object, or more accurately, assign the same object to multiple variables. When an object, such as a vehicle, is respawned through a respawn module, or when a player respawns, the object doesn't truly respawn. Instead, a new version of the object is created, and this new object is set as the new value of the variable name assigned in the editor. So, when an object respawns, the variable name updates its value and rebroadcasts it. It's also possible to assign the variable name to another object through scripts. When you use that specific variable name in a script later, you will refer to the new object that has been assigned to that variable. However, this new object will not respawn with this given variable name. If the previous holder of the variable name respawns, the newly spawned object will be assigned the variable name. So when using a variable name, you are referring to the object that is the current value of that variable. However, problems arise when using local variables. A local variable does not store the variable itself, but rather the value of the variable. For example, if _ambulance is equal to ambulance_2, it means that _ambulance now refers to the specific object that ambulance_2 was referencing. If a new object is assigned to ambulance_2, the local variable _ambulance will still hold the previous object as its value because its value can't be redefined outside the script, kind of. This means it will still refer to the old object that was associated with ambulance_2. However, here is the kind of, if that old object is removed, _ambulance will return null. While we can update the value of a local variable so that it references a new object, a problem occurs when using a variable name passed through the argument array used to call a script. In this case, there will be no real update because the argument will refer to the value of the variable at the time the script was called. To solve this, we convert the variable name to a string. This allows us to save the name of the variable itself, not just its value. By saving the name, we can use it later to redefine a local variable using getVariable. Because, as said, a variable name is really just a variable in the mission namespace. So if we have the name of the variable, we can set the local variable's value by setting it to be equal to the variable in the mission namespace. I hope this explained it. Now with that knowledge and the 3 local variables done, we can create the last variable, which should also be placed outside the loops. This variable is the one that will refer to the object and, therefore, use the string we created in _saveAmbulance. Now write down _ambulance equal mission namespace getVariable _saveAmbulance. We are not going to make this private because there is no point in doing so. What this code does is it will retrieve the value from the variable stored in the mission namespace with the name who matched the string in the local variable _saveAmbulance and set it to be the value of _ambulance. Now just paste in _ambulance where the object's variable name is, _spawn marker where the respawn marker's name is, and _fallback pose where the fallback position marker is. Now we have a problem. Previously, we suspended the loop with a wait until that checked whether the connected object was alive again. Using a public variable works fine for that because its value can be changed outside the instance. However, the problem arises when using a local variable, as it can't be changed outside the instance. This means we can't check for _ambulance becoming alive again because it will never happen if it is already dead. However, we can check if it becomes null. If the object saved in the local variable gets deleted, the variable will return null. This means if, for example, you have a script that deletes the body of the respawned player or the wreck of the respawned vehicle, then the object will no longer exist and the value will become null. If you have a setup like this, you can simply go to the wait until statement and replace alive with isNull. If you are doing this, you also need to move the line of code that sets the value of _ambulance down into the outer loop. This line should then be the first line in the loop and above the inner loop. And that's it for this script. If you have a setup that deletes the bodies of players or the wrecks of vehicles, this script is finished. But maybe you don't have a setup like that. Maybe you want the bodies to be left behind or the wrecks to remain. How should you solve this then? With another loop. We will replace the wait until statement with a new while loop. In the condition for the while loop, we will set it to be not alive _ambulance. Then, inside the do bracket, we will paste in this code again. underscore ambulance equal mission namespace get variable underscore save ambulance. Now by choosing not to make this variable private, it's going to overwrite the variable underscore ambulance. This means the condition checking for the ambulance to be not alive in this inner loop will react when underscore ambulance is alive again. As said earlier, the problem with using a local variable is that it can't have its value changed outside the instance. So if we want to check if the object has respawned, we need to set the variable's value each time before we check. That is what we do here. After this line of code, we will add sleep 5. And now this inner loop is complete. Now, when the object is eliminated, it will break the first inner loop, set the marker to its fallback position, and then start the second inner loop. When the object respawns, the second inner loop will assign the local variable the new object, which will break the second inner loop. Then, the outer loop will loop back into the first inner loop, now following the new object. And that's it! Now you never really need to touch this script file again, besides maybe changing the time between each round in the loop. If you want to use this now, just copy the file into the folder of that mission you want and call it from the init server, sqf. Then just put down the variable names for the object and the markers inside the square brackets. If you want to use this script more than once in a mission, just copy the code calling this script and change the variable names to fit the object and markers you want to use. It doesn't need to be a respawn marker either. If you just want to have a marker follow an object to show where it is, you can also use this script with no changes needed. And if you want to take this to another level, you could also change the static number in sleep to a variable. That's something we are going to look at in the next script in the silver tier, so stay tuned. In the first part of this round, we looked at one way to define variables with arguments from an array. In this part, we are going to look at another way to do that. Additionally, we will also ensure that the script stops if some of the arguments given are wrong. As it is written in the previous part, if you feed the script wrong arguments, it will throw an error but still continue, and that's not good. What we want is that if you feed the script with wrong arguments, then the script will exit itself. As in the last part, for easier understanding, we will first start by filling in the arguments in the array in front of the execvm call to the script mobile respawn underscore b. So head back to init server, sqf. Inside the square brackets before execvm mobile respawn underscore bsqf, we are going to make a list with 3 arguments. The first argument is going to be the variable name for the object you want the marker to be connected to. Here, I'm going to write ambulance underscore 3. After that, write the marker you want to move. So for me, respawn underscore east underscore 3. Remember to write the names of the markers as strings, using quotation marks. The last argument in this list is going to be a number, which is how long you want the sleep time in the loop to be. Here, I'm going to put down 5 since I want the loop to pause for 5 seconds. The first and last arguments should not be written as strings. So the array is going to look like this: ambulance underscore 3, respawn underscore east underscore 3, 5, execvm mobile respawn underscore b sqf. With that done, we can move into the mobile respawn underscore b sqf file. Previously, we used the command select to define which local variable corresponds to which argument from the input array for the script. In this script, we are going to use the command param to define which local variables correspond to which arguments from the input array. The param command looks like this. Argument param index default value expected data types expected array count. Argument. This can be anything. Like for example, it can be an array, a string, an object, a number, or something else. If it's not an array, the data is going to be converted to an array. It's the data inputted into the command param. It is required, but if one uses this inside a called script and one has not defined the argument, it will default to underscore this. Param is the command. Index, this is a number and is required. It is the position of the element selected from the array passed to the command. The numbering of positions in an array starts with 0, not 1. So to select the first element, one needs to use 0, then 1 to select the second element, and so on. The selected element can itself be an array if it is an argument in the input array. So they can be arrays within arrays. Remember, if one has inputted a non-array value in the argument, that value is converted to a one-element array and still needs to be selected. Default value. This can be anything like an argument, so an array, string, an object, a number, or something else. This parameter is not required if no argument has been added to the input array for the selected position. The output value of the command param is going to be what has been assigned in this parameter. The same will be true if the argument in the input array doesn't meet the requirement set in this command. Expected data types. This is an array and its elements need to be the type names of the data types. The elements may be array, boolean, group, scalar, object, string, and so on. You can find a list of the names of the data types on the page type name on the Bohemia Interactive Community Wiki. This parameter is not required. This parameter defines what data types are accepted as possible values for the command. If the selected arguments in the input array don't match any specified data types, it will throw an error, and the output value will fall back on the value set in the default value parameter. An array without elements means that every type is accepted. Expected array count. This can be either an array of numbers or a single number. This parameter is not required. This defines the accepted element size if it's an array. So, if you have written 2 here, then the size of the array you put in the input array needs to be 2 elements, no more or less. But if you write, for example, an array with 1, 2, the selected array can be of single size or 2 sizes. If not, the output value will fall back on the value set in the default value parameter. An array without numbers means that every size is accepted. With this, we can start writing the first local variable. Private underscore ambulance =, underscore this param 0, fail object, object. The setup looks similar to the setup when we used select, as we start as before by making the variable private. Then we have the name of the local variable. This time it's named underscore ambulance. Then we define the local variable with the command param. Here we see the argument passed to the command is underscore this. But since we are using this command inside a called script, we can remove this parameter and still get the same effect. Then we have the command itself with an array of parameters helping define the value it will output. The first element in the array is the index parameter. We have 0 here since the object's variable name is written as the first element in our input array. Following the index, we have the default value parameter, which is a string with the text file object. This means that if the first element in the input array is either missing or not of the desired data type, the variable's value will become file object, which we will check for later. The last element in the array is the array of accepted data types. This array contains a single element, obj null, specifying that the only acceptable data type is object. And that's the first local variable defined. Now we can move on to defining our next local variable, which will be the local variable for sleep time. I'm doing this to demonstrate that the order of local variables does not have anything to do with the order of arguments in the input array. Instead, it is the number after the command select and the index parameter in the param command that connects the element to the variable, not the order of the variables in the script. However, I recommend writing the local variables in the order of the corresponding elements for better readability. So our second variable will look like this. Private underscore time equal sign underscore this param2. 3. 0. As before, we start with private. Next, we have the name for the variable. We then define this variable using the param command, which takes underscore this as its input array. The element it should retrieve from the input array is the third element. So in the index parameter, we use the number 2. The default value is set to 3, and the accepted data type is a scalar, so we write a 0 here. Therefore, if nothing is assigned, or if something other than a number is placed in this slot of the input array, the variable's value will default to 3. Now our last variable is going to be the variable for the marker. Private underscore spawn marker equal sign underscore this param1 fail marker quotation marks. We start with private, then underscore spawn marker to create the variable. We use the param command to define the value of the variable. As before, we use underscore this to select the input array. Since the name of the marker is the second element in the array, we use 1 in the index. We then have a string with the text fail marker. As before, if the argument in the selected slot doesn't match what we have set as a requirement, then this is going to become the fallback value. The last parameter in the following array is an array with a single element quotation marks, which defines that the only data type that can be in this slot is strings, or the value of the variable is going to become fail marker. Now that we have finished defining the parameters in this script, we will write 2 exit with statements. An exit with statement will exit the current scope if the condition returns true. We will use this to stop the script if either the object or marker variables return their default values. Our first exit with statement will look like this. If underscore ambulance is equal to fail object, exit with system chat failed because argument is not an object. This is the condition for the statement to be fired. It needs to be true when the script passes this statement to activate. If it is false when it passes and then turns true later, nothing will happen. Our condition here is that the variable underscore ambulance must have the value fail object, which is the default value we set. If this condition returns true, the script will stop at this point and exit with the command inside its brackets. The command we wanted to exit with is a system chat message informing us that the script failed because the argument is not an object, it's not required, and you will get an error message if the data inputted doesn't match the expected data type, regardless if you make this setup. But this will not mean that the code has exited, that's why we created this exit with statement. The other exit with statement has a similar setup. If underscore spawn marker is equal to fail marker, exit with system chat failed because argument is not a string. The only differences are the variable name, which is now underscore spawn marker, and the value, which is fail marker instead of fail object. Additionally, the system chat message will indicate that it failed because the argument is not a string instead of an object. The best location for these 2 statements is right after the connected variable, so the first statement will be right after our first variable, and the second statement will be right after the third variable. We are doing this to break the script before it continues down its lines, because why let it fire more codes than necessary? Therefore, we can also change the order of variables, so the third variable becomes the second variable. Now the only thing left in this script is to replace ambulance underscore 3 with underscore ambulance, respawn underscore east underscore 3 with underscore spawn marker, and the number 3 after sleep with underscore time. Since this loop will stop when the object is destroyed and will not start again afterward, we don't need to think about how to make it work when the object respawns. Meaning we are done here. As with the last script, you never really need to touch this script file again. If you want to use this now, just copy the file into the folder of that mission you want and call it from the init server SQF. Then just put down the variable names for the object, marker, and the number of seconds the loop will pause inside the square brackets. And if you're unlucky and write something wrong or miss something, the script will exit itself and you will get a message in the chat when you are testing it. You will also get an error message, regardless of whether you have a system chat message or not. But there is a but here. If you write a string in the second element in the input array that is not a variable name for marker, it will not throw an error since it will just check for strings and not markers. So beware, it's not completely foolproof. Always test your missions. So let's test the two scripts we have modified so far. The first will be our newest script where the loop will break. We see here that the part with moving the marker works. It seems to work. The second test will be our first modified script. The marker is following us as it should. Then it moves to the fallback position. The vehicle responds, but the marker is not yet connected. But there it connected. And it follows again. We should have enough knowledge now to finish the last part of the silver round. So let's dive into that. So, let us finish the last script in this round. In this script, we are going to make 4 possible arguments. 2 required and 2 optional arguments. The 2 required arguments are going to be the object the marker is connected to and the marker itself, while the 2 optional arguments are going to be the sleep time for the loop and the sleep time for the wait until. We want this script to have the same continuously setup as the last script, so if one of the 2 required arguments is wrong, the script will exit itself. We also want the sleep time for the wait until to be the same as the sleep time for the loop, if you haven't specified otherwise. Since we are dealing with a respawning object, like in the first script in this round, we need to turn our object into a string. That is our plan for the arguments we can set when we call the script. We also have the 3 codes that set the type, color and text of the marker. We want these to be dynamic and not connected to static code, but in this script we will not turn them into possible arguments. Instead, we will just pick them from the pre-placed marker. With this, we can start modifying our script mobile respawn_c. So, as before, head to init server, SQF. Then inside the square brackets, before execvm mobile respawn_c, make this list with these arguments. The first argument is going to be the variable name for the object you want the marker to be connected to. Here, I'm going to write ambulance_4. After that, write the marker you want to move, so for me, respawn_east_4. Remember to write the names of the markers as strings, using quotation marks. The last 2 arguments in this list are going to be numbers. The first number is how long you want the sleep time in the loop to be. Here, I'm going to put down 5. Then I'm going to put down 7 for the wait until time. And remember, only the marker name should be written as a string. So the array is going to look like this: ambulance_4, respawn_east_4, 5, 7, execvm mobile respawn_c sqf. Then open the mobile respawn_c sqf file. For assigning the local variables the different arguments, we are again going to use the param command. So let us start with the first local variable, outside the loops. Private underscore save ambulance equal str underscore this param 0 fail object obj null. It's mostly the same setup as in the last script. The only difference, besides the name, is that we are using the command str to make the value that comes out from the param command a string. This is because when an object respawns, the object connected to this local variable is not going to follow after. So we need to reset it, and to do that we need the specific name of the variable who has the same name as the object, therefore we turn it into a string to save it. The downside is that this will also turn the string fail object into the string quotation mark fail object quotation mark, so we need to keep that in mind. If underscore save ambulance is equal to str quotation mark fail object quotation mark exit with system chat failed because argument is not an object, we want to have this right after to stop the script if the first variable is input incorrectly. There is no need to continue the script if that one is wrong. It's similar to the same statement as before. The only difference is that we are using the command str around the string file object. This is because when we use the command str when defining the local variable, the default value, which is already a string, will get stringified again, and the marks making it a string is also converted. After that, we define the second local variable, the spawn marker. Private underscore spawn marker equal underscore this param 1 fail marker quotation marks. Nothing to comment on here. You see that this line is the same as in the last script. We follow this code line with the second exit with statement since this is the second required parameter. If underscore spawn marker is equal to fail marker exit with, system chat failed because argument is not a string. Again, no difference from the previous script. Now, after the two variables connected to the required arguments are done, we can move on to the two optional arguments. The first one is going to have the same setup as the time variable in the last script, so it is going to look like this. Private underscore time equal underscore this param 2 3 0. Then the second time variable is going to use this first time variable as its default value, meaning that if you don't assign a specific time to the second time argument, then it's going to use the first value. To do that, we just replace the default value with a variable underscore time. Private underscore time wait equal underscore this param 3 underscore time 0. This means that even if the first variable is not defined with underscore time or has a wrong argument, underscore time is going to default to 3 and underscore time wait is going to follow after. Now, before we head down into the loops and start replacing the specific objects, markers and times with these variables, we will also set up 3 local variables for the type, color and text of the marker. To get this information, we are going to use the commands marker type, marker color and marker text. They have the same setup, like this. Marker type marker. Marker type returns what type the marker is, marker color returns the color, and marker text returns the text. Marker is the marker the command scopes to. So our 3 variables for this information will look like this. Private underscore marker type equal sign marker type underscore spawn marker. Private underscore marker color equal sign marker color underscore spawn marker. Private underscore marker text equal sign marker text underscore spawn marker. These 3 variables will store the information about the marker our chosen marker is, so we can call on it later. Now with this, we have only one variable left before entering the loop. That is to define our object, like we did in the first script in this round. We will use this line to do that. Underscore ambulance equal mission namespace get variable underscore save ambulance. Now we are going to tackle the inner loop. So first head into the while condition in the inner loop and replace alive ambulance underscore 4 with alive underscore ambulance. Then inside the inner loop, replace the line. Respawn underscore east underscore 4 set marker pose ambulance underscore 4 with underscore spawn marker set marker pose underscore ambulance. And change out sleep 3 with sleep underscore time. Now the inner loop is finished. Next, we can finish up the outer loop. Replace delete marker respawn underscore east underscore 4 with delete marker underscore respawn marker. Then head down to wait until and replace the statement wait until sleep 3 alive ambulance underscore 4 with our loop from the first script while not alive underscore ambulance. Do underscore ambulance equal mission namespace get variable underscore save ambulance sleep underscore time wait. Then we move further down the loop to create marker respawn underscore east underscore 4 ambulance underscore 4. Here we replace that line with create marker underscore spawn marker underscore ambulance. Then after this we just replace respawn underscore east underscore 4 set marker type lock underscore hospital with this underscore spawn marker set marker type underscore marker type change out respawn underscore east underscore 4 set marker color op 4 with this underscore spawn marker set marker color underscore marker color, and the last replacement is this respawn underscore east underscore 4 set marker text remove and reappearing with this underscore spawn marker set marker text underscore marker text. And that's it. Now you just need to fill in the information when calling the script about what object and marker you want to move, and time if you really want to change it, and you don't need to do anything else. The marker will follow the object. And when the object is destroyed, it will get removed then respawn with the vehicle, with the same marker type, color and text as you had at the start. One downside is that this marker will always respawn with the setup you had at the start. So if you make it so the type, text or color changes mid-mission, you may need a script to do the changes after respawning. And congratulations! You have now finished the silver round. You should now have an understanding of how to create dynamic and reusable scripts by using arguments when calling the script and connecting them with the commands select and param to local variables. You should now also have an understanding of how you can prevent your script files from running when you have filled in some bad information. You should be able to leave with this knowledge, as every version of these loops we have created can stand on its own. You also now have a database of different scripts you can choose from. Bronze and silver are done. It's time to reach for the gold. So far, we've based our scripts on creating the marker we use in the editor. Our next step will be to create the marker entirely through the script without the need to create it in the editor. This means the only thing we need to place in the editor is the object the marker will be connected to. In this part of the tutorial, we will focus on modifying the last script we finished in the silver tier. Additionally, we will add a statement that will remove the marker and exit the script if the object is destroyed and a specified condition is met. This statement will be based on an argument you set when calling the script, giving you more modability in how the script behaves. We will also look at a way that allows you to break the loop by setting a special variable on the object. This feature can be nice to have if you want players to set specific vehicles as moving respawn points, or in a PvP mission where players have the ability to capture the opposing team's respawn points. With our plan in place, let's get to work. First, copy the mobile respawn underscore C SQF file and rename the copy to mobile respawn underscore D SQF. Now open this copy. The first thing to do inside here is to remove the 3 lines that define the local variables underscore marker type, underscore marker color, and underscore marker text. Do not remove the instances where they are called, just leave those as they are. Then move the line that defines the local variable underscore time and underscore time wait by 4 lines. We are going to create 4 new local variables, each with a parameter connected to it. This means that after this, you will have 8 possible arguments to fill in when calling this script. The first local variable will be a boolean and will be used to decide if the script should continue or exit after deleting the marker. The default value for this variable will be false. We will place this variable right under the exit with statement for underscore spawn marker. Let's write this variable. Private underscore bool equal underscore this param 2 false true. This local variable will be the third argument in the input array. Its default value will be false, and this value will be used later when an exit with statement checks if the script should exit. The expected data type has been defined as boolean by setting its name type to true. The second new local variable we will create will be named underscore marker type and will have the value as a string. Previously, we created a local variable with this name that saved the type of the connected marker. Now, we are creating this variable to allow customization of the marker type that will be created. This variable will be placed under the previous one. Private underscore marker type equal underscore this param3 empty quotation marks. This variable will be the fourth argument in the input array. Its default value will be the string empty. So if you don't set anything, the default marker type will be an empty marker. The expected data type is defined as a string with quotation marks as its name type. The next local variable we are creating is also a string, named underscore marker color. As with the previous variable, we have already used this name earlier, but now we are using it to allow customization of the marker's color. This variable will be placed after the previous one. Private underscore marker color equal underscore this param4 default quotation marks. With the number 4, this will be the fifth element in the array. The string default is the default value. So if you haven't set a specific color in the array, the marker's color will default to the marker's default color. The expected data type is set as a string with the use of quotation marks as its name type. The last new local variable is also a string, named underscore marker text. As with the last two variables, we have used this name before, but now we will use it to set the text for the marker created in this script. This variable will be placed under the previous one but above the underscore time variable. Private underscore marker text equal underscore this param 5 quotation marks. This variable corresponds to the sixth element in the input array. It will have a default value of an empty string, and the expected data type is set to be a string. One thing to note with these two string variables is that if you input a string in their respective array elements, but the strings are not valid types or colors, it will throw an error. However, the default value will not be used. The last variable, which is just the marker text, cannot cause an error in this way. Next, we will change the placement numbers of underscore time and underscore time wait from 2 and 3 to 6 and 7, respectively. Underscore time will now correspond to the 7th element, and underscore time wait will correspond to the 8th element in their array. Now, we have finished creating the local variables connected to the arguments that can be passed when calling this script. Even though there are now 8 possible arguments, only 2 are required: the name of the object and the name of the marker. With this done, we can move on to creating the marker. We already have the code for this written inside the outer loop, and if we want, we could move these 4 lines up before the inner loop, so the marker is created when the loop begins. To do this, move these 4 lines up, right above the inner loop. Then, we can add a small sleep timer between the last of the 4 lines and the inner loop, and that's all we need to do to create the marker. The last thing we need to do is head down to the outer loop. Right under the delete marker command, we will add a new statement, an exit with statement, so we write if exit with. Now, inside the if condition, we will use this variable, underscore bool. So it will be if underscore bool exit with. This variable is the local Boolean variable we created earlier. When it's false, which is the default value, nothing will happen. But if it's true, then when the script reaches this statement, it will exit. With this, all the scripting inside the script is finished, so we can now head over to init server, sqf, and call the script with the command execvm mobile respawn _d sqf, as we have done with the other scripts. Then let's fill out the input array. First, I will demonstrate that you only need to specify the object and a marker's name to get this to work. For instance, I'll use ambulance _5 for the object and respawn _east _5 for the marker name. If I open the map now, you'll see that there are no markers. However, when I respawn, you will see that I can respawn at the specified location. Okay, now back to the array. If I want the script to stop when the connected object is destroyed and not restart when it respawns, I need to put true in this position. But if I want the script to continue, I can either write false or nil, or leave it blank if I don't need to continue the array. However, if I want to specify the marker type, I need to put something here. So I'm going to write nil. The next element in the array is the marker type. As mentioned earlier, you can find the available marker types in CFG markers, Arma 3, on the community wiki. It needs to be a string, but if you don't want to specify a type, you can write nil. In this case, I want the marker to be a truck marker, so I'll write lock _truck as a string. The following element is also a string, representing the argument for the color of the marker. Since I don't care about the color in this instance, I'll put in nil. However, if you want a different color from the default, you can find a list of colors on the CFJ marker colors Arma 3 page in the community wiki. Next, we have the element for the marker's text. This also needs to be a string or nil if left empty. I want the marker to display the text respawn truck, so I'll write respawn truck as a string. The element that follows is the sleep time for the inner loop. I want this to be 7 seconds, so I'll write 7 here. The last element is the sleep time for the second inner loop. If not specified, this time will be the same as the sleep time for the inner loop. Since I want them to be the same, I'll write nil here as well. Now let's test this. When I start the mission, we can already see the marker on the map with the specified text. When we move the object, you'll notice that due to the sleep time, the marker follows us but with a slight delay. When we respawn, the respawn point appears as a possible respawn point. If we destroy the object, the marker will disappear, and so will the respawn point. However, if the object respawns, the marker will also reappear. But we're not finished yet. We have still a small change to this script left. You can either make a copy of this script file and open it, or simply reopen the current version. The change involves using the following code: _ambulance, get variable, _spawn marker, false. This code checks if the object has a variable with the name of the marker. If the object doesn't have this variable, it will return false. We will incorporate this code in 2 places: in the while condition for the inner loop, and in the if condition within the exit with statement in the outer loop. First, let's look at the while condition in the inner loop. The current condition checks if the object is alive. We want to modify this condition so that it checks if the object is alive and does not have the specified variable. We'll use ampersand to add an AND statement followed by our code, _ambulance, get variable, _spawn marker, false. However, we need to turn this condition negative since we want it to check if the object does not have this variable. To do this, we'll wrap the code in parentheses and place an exclamation mark, which represents not in front of it. So our new condition will be alive _ambulance and not _ambulance, get variable, _spawn marker, false. Now if either of these conditions returns false, so either the object is dead or has the variable, the inner loop will break. Next, let's move on to the exit with statement. The current condition is just _bool. We want to modify this condition so that it checks if either _bool is true or the object has the marker variable. We'll write the condition like this: _bool or _ambulance, get variable, _spawn marker, false. This means that the outer loop will exit if either _bool returns true or if the object has the variable named after the marker. With this setup, you don't need to worry about the variable most of the time. However, if you want to break the loop, just add the variable to the object and the inner loop will stop, the marker will be deleted, and then the outer loop will exit. To add the variable to an object, use the following command: object, set variable, marker name, true, true. Here, replace object with the name of the object variable. In my case, I'll use ambulance _5. Then, for marker name, I'll use respawn _east _5. The first true sets the value of this variable to true, the second true makes it public. If you execute this code in a multiplayer season on another computer in a local setting, you'll want this to be public. If you run this locally on the server, it can be false. Writing nothing here will be the same as false, so I will leave this blank. So, the command would look like this: ambulance _5, set variable, respawn _east _5, true. If I trigger a command with this code now, you'll see the marker disappear. You will also notice that I may encounter some issues adding a marker with the same name to the same object again. If I want to remove this variable, I'll use the same code, but instead of true in the value element, I'll use nil. Ambulance _5, set variable, respawn _east _5, nil. If I try it now, you'll see that the script works fine as before. Then I can add the variable again, and the marker will be gone. Congratulations! You have now completed the gold round. You should now have the knowledge to create mobile respawn points that appear either at the start or later in a mission, without needing to create markers in the Eden editor, just by calling the script. You should also have an understanding of how to set things up, so you can break one of these mobile respawns, aside from simply destroying the object. This means you can manipulate them in various ways, such as removing or adding a respawn when an object is done. And that's it! If you'd like to stick around to stretch out this video by learning how to set up functions, you're more than welcome to do so. If not, thank you for watching. If you have questions or want more information, feel free to leave a comment about it. And now it's time to stretch out a bit because there's a little more to talk about. If you want to call a script multiple times in a mission, it's smart to turn that script into a function to save on performance costs. However, if you're only planning to use the script once, there's no real need to make it a function. So let's take a look at how to convert our last script into a function. To do this, we need to edit the description, ext file. If you don't have one, create it. Open the file, and inside it, we're going to create a class called CFG functions. It will look like this. Class CFG functions. If you already have one, great, you don't need to create a new one. Inside the CFG functions class, create a new class. This will be the tag class. For this tutorial, let's call it tist, but you can name it whatever you want, just don't use a name that's already in use. This tag will appear in front of the function name when we want to call it. By using the command tag =tag, you can set it so that two different tag classes share the same tag. Next, inside the tag class, create another class. This will be the category class, and we'll name it mobile response. After that, we'll create another class inside the category class. This will be the function class, and we'll name it mobileresponse_d. This is all we need to write inside the description, ext file to define the function. Now, we just need to create the folders where we place this function. First, create a folder called functions. Inside that folder, create another folder with the same name as the category class, so the folder will be named mobile response. Inside that folder, drop the mobile response_d sqf file and add this prefix to the file name, fn_, so the file will now be named fn_mobile response_d sqf. If you want to store the file in a different location, you can specify the file path inside the category class, like this, file =folder. If the folder is inside another folder, just add the full path. For example, in our case, the path would be file functions/mobile response. To call this function, use the spawn command instead of call, since the function contains suspensions. To spawn this function, write it like this. Arguments. Spawn. tist_fnc_mobile respawn_d. Arguments. Here you place the arguments like before. The function name consists of the tag from the tag class followed by the prefix fnc. Note that this is not the same as the fn_ prefix we added to the file name. Finally, it includes the file name without the prefix and file extension. And that's it for creating a function. I hope you now understand how to make and break loops, how to connect arguments to variables, and how to set up functions. As mentioned at the beginning, this is the first part of a tutorial on how to create mobile respawn points, focusing on using loops. The next part will focus on using event handlers. Thank you again for watching. If you learned something new or found this tutorial helpful, a like would be wonderful. This may be my longest tutorial yet, so I hope the next one will not be on the same length as this one, who at the moment of recording is on 29 pages.